Greetings and welcome. In this video, I will demonstrate how to use the OR spectrometer from Thunder Optics. You will need a computer equipped with two softwares, one for the laser and one for the spectrometer itself. Then the laser, which is connected to our Raman probe with a 200 micrometer fiber. You will need the OR spectrometer, which is the core of this manipulation. The spectrometer is linked to the Raman probe with a 600 micrometer fiber. So this is 200 micrometer, this is 600 micrometer. And finally, you will need this table and the Raman probe itself. In this manipulation, I will demonstrate how to obtain the Raman spectrum for a quartz sample. So let's go ahead and place it right under the laser, around here. Before turning on the laser, please use protection glasses. These ones are for 532 nanometer, since it is the laser we are using. For this measure, please make sure that we are in raw data and fast acquisition mode. Both these settings are essential to a good measurement. So the first step on the software will be to click on dark here. This will give us a dark spectrum. Now we can turn on the laser. So here I'm going to push the button. This will turn on the laser, but you do not see yet the laser itself. It's because here it's off. So you can see that it is connected. Same on tender view, right under here. You can see that the spectrometer is online. Now I can turn on the laser and set it to continuous. So here we can see that we have a problem. The curves are superposed. So we will stop the acquisition. Go into settings, curve counts, and select one curve. Now we will only see one curve at a time. Perfect. Finally, we'll have to go in algorithm and click on baseline correction. Perfect. So now we can go ahead and get our continuous spectrum, and we'll have to optimize the spectrum because here you cannot work with that. So on the probe itself, we have to lower it or move it up depending on where you're situated. So in my case, I will lower it slightly until I get a good signal. So here we can see the apparition of the quartz peak. In order to optimize, I will go slightly lower. Here we can see that we decreased the peak, so I have to go slightly above. Move up. Well, this should suffice. So here, this is the preliminary settings. This is not the final measurement. So we have to stop signal. Now that we are pretty well placed, we can still optimize it. So let's turn off the laser. Let's clear our curves. For example, if we want to increase the acquisition, the integration time, we can click here. We can even set it to milliseconds if we want, but for now, let's say 2 seconds is fine. And if we want to scan to average, meaning average the signal on multiple scans, we can increase it here. So let's say that 2 by 2 is fine. We will get our dark spectrum. Perfect. We have to baseline correction it. So this is our dark spectrum. Now we can turn on the laser again and get either a continuous or single scan, since we are doing a single measurement, I think here. And here we go. We have our quartz peak. Finally, if we repeat these last few steps of having to tune the wheels, so coming closer or farther from the sample, and taking a dark spectrum, then taking a single acquisition or continuous acquisition, you can try to optimize the signal and you can obtain this kind of signal.